My name is Kelly Paffel. I'm Technical Manager for Invino Engineering, LLC, located in Tampa, Florida. We're a domestic and international engineering company, specifically in the field of steam and condensate systems. I'm doing the presentation today, Waterhammer and Steam and Condensate Systems, with our senior field engineer, Graham, and we'll go through what causes Waterhammer, solutions, and operations. Waterhammer is not only a system issue, it's primarily a safety issue. People get hurt all the time due to Waterhammer issues in the plant. Understanding the nature and severity of Waterhammer in a steam and condensate system will allow a facility to avoid its destructive forces. You cannot restrain the forces of Waterhammer, and the plant should never have Waterhammer. So this presentation is going to be in 3 segments. The first segment is understanding the dynamics of Waterhammer, and then the 4 types of Waterhammer and the solution to Waterhammer. So what causes Waterhammer? Then the next thing we're going to talk about, changes needed to prevent Waterhammer. System designs, system engineering, installation, operation, steam system startup. The thing with Waterhammer, change must occur to eliminate Waterhammer. It is an abnormal operation. Unfortunately, 82% of the steam systems in North America are experiencing some type of Waterhammer. It's very unusual that we walk into a facility or plant and ask them if they have Waterhammer, and the answer is no. The typical answer is yes, but it's not too severe today. Waterhammer is unavoidable and natural part of the steam and condensate system. This is an entirely false statement. You should never have Waterhammer. And Waterhammer is an international issue. No matter where we go, if we go to Thailand, Singapore, Germany, France, wherever, the steam systems are occurring Waterhammer. Why does Waterhammer occur? It can occur in the steam and condensate system. So example in the steam system, one of the things that causes Waterhammer, too fast of startup or energizing the steam system. A plant needs to know what the proper time frame for starting up a steam system. If it's not known, then a rule of thumb is 1 psi per minute. But taking time to allow the system to warm up gradually, at startup the highest condensation will be generated, heating the massive pipes up to temperature. Also, the expansion will occur at that same time. Steam trap stations on steam lines that are shut off are not in operation. This is a very unsafe practice. All steam trap stations need to be in operation. No matter how well we insulate the steam lines, condensate is going to occur. We have to remove the condensate out of the steam system to prevent Waterhammer. The next thing is lack of steam trap stations in strategic locations. Where do we need steam trap stations in the system? So the system design has to place the steam trap stations in strategic locations to ensure that we get the condensate out and that we don't have buildup and we don't have Waterhammer. Condensate systems. Two-phase systems contain 2 states, a liquid and condensate, and a vapor, which is flash or generated steam. And what was meant by generated steam, steam that's flowing from a failed steam trap or a bypass valve into the condensate system. The two-phase condition exists when condensate coexists with the generated or flash steam. Condensate line velocities can never exceed 4,500 feet per minute. So the thing is that at steam lines, we go up to 10,000 feet per minute. But at condensate lines, we only want to be at 4,500 feet per minute. The other thing with condensate lines, we need to design them. If you're not going to have a proactive steam trap maintenance program, then we have to upsize the condensate lines for the additional steam that's going to be allowed to flow into the condensate line so we don't exceed 4,500 feet per minute. Condensate needs to remove as quickly as is formed from the process applications. Process applications in steam, 99.5% of them are designed for condensate to be removed as quickly as possible. They're not designed for flooded conditions. Undersized or improper sized condensate removal devices that allow condensate to back up into the process unit will cause water hammer. Sizing steam trap is as critical as sizing a control valve in the system. So take the time and the effort to size the steam trap correctly. Understand the dynamics of the system. A steam trap is an orifice. You need to know P1 and P2. The other thing is high condensate line pressures. And not knowing the condensate line pressure or P2 on the outlet of the steam trap is critical. And the thing about condensate line pressures, they can vary depending on the dynamics of the system. So we have to know the highest condensate line pressures. Eliminate water hammer. Like I said, change must occur. Abnormal operation is pipe movement, banging noise, pinging noise, component movements. The normal operation should be no noise, no movements. So don't assume normal operation does have pipe movement, banging, pinging noise, and component movements. That's not normal. That's abnormal. The normal operation is when you walk in your facility, you hear no noise, no movement. An example would be here in this video here. As you can see, the pipe movement here is occurring from the water hammer that's occurring down in this tank operation. So the thing is, you can't restrain water hammer. So we have to eliminate water hammer. It causes too much damage in our operation. The results of water hammer: steam and condensate line failures, steam lines being ripped open, pipe welds failing, flanges leaking, failing, supports broken, damaged, guides damaged or broken, elbows and piping removed from the system, flow meter units damaged, not functional, valve failures, body failures, internal mechanism failures, heat exchanger failures, tube failures on shell and tube, gasket failures can be on shell and tube, plate and frame, and shell damage itself. So water hammer can cause a multitude of things. Pressure gauge failures, internals failing, pump failures, condensate pump failures, steam trap station failures. Steam trap bodies failed, check valves. There is no steam trap that can withstand water hammer. So therefore, we have to eliminate. A root cause analysis, one of the biggest things that cause steam trap failure is water hammer. Evidence that we gather by doing root cause analysis in plants, which is in the steam and the condensate component failure, suggests water hammer causes 67% of the premature component failures. On root cause analysis, 67% of the component failures are due to water hammer. So it's not only a safety issue, it's a huge reliability issue that we must eliminate in the steam and condensate system. Types of water hammer. There's 5 major areas of water hammer: hydraulic shock, thermal shock, flow shock, differential shock, and flooded shock. And this will conclude the first segment of the water hammer. The next segment is we'll go through each type of water hammer and explain what causes that water hammer.